Hello, we are Team 22033, working on the Enrichment Dispersal Unit with Reed Park Zoo. My name is Avery Anderson. I am the Systems Engineer and Team Leader for the project.
Hi, my name is Alan Lafferty. I'm a computer engineer and the procurement lead.
My name is Tyler Hedrick, and I'm an electrical engineer.
My name is Carolyn Volker, and I'm a mechanical engineer.
Hi, I'm Matt Dromgoole. I'm a mechanical engineer.
Reed Park Zoo approached the University of Arizona Senior Design Program looking for unique ways to provide enrichment to animals inside the zoo. More specifically, they were looking for a remotely activated enrichment dispersal unit. For those unfamiliar with animal enrichment, it is essentially the process of improving an animal's habitat by providing stimulation that encourages the use of their senses and their natural behaviors. For the purpose of this project, Reed Park Zoo was specifically looking for ways to deploy physical enrichment items such as those pictured here to habitats in the zoo. In the early stages of the project, our team met with Reed Park Zoo staff in order to determine which habitats might benefit most from the integration of an enrichment dispersal unit. We determined that the best location for the EDU would be the Andean bear habitat. This decision put a few unique restrictions on the project. As you can see, this would mean that we're placing the final product behind the back wall of the habitat. This wall is 11 feet tall and approximately 5.5 feet wide at its thickest point. We also had a footprint of 4 by 4 feet that the design was restricted to. Using these unique habitat characteristics and other goals outlined for us by the Reed Park Zoo team, we were able to get together as a team and outline a set of system requirements to guide our future design and building of the device.
Using these requirements, our team developed 3 possible options for our solution. The first one, a mechanical arm that would take preloaded buckets and deposit it over the wall. The second, a vertical conveyor system where the buckets would be attached to the system. Or option 3, a rotating box which would be loaded on top of the wall.
Our team decided to use a Pugh Analysis in order to narrow down these 3 options and select our final design. In this Pugh Analysis, we ranked many different factors, and ultimately, we considered animal safety, moving parts, complexity, ease of use, and cost risk to be some of our most important factors, and weighted them accordingly. As you can see, we assigned a score for every single design that we were considering to each factor, and calculated a total score for each design. The lowest total score signified the least risky design, and that design was the conveyor belt, which the team ultimately selected to continue designing.
We began our design with a conveyor belt that had enrichment buckets attached to it that would deposit the items onto an enrichment slide. Upon further analysis, we realized that this design would not be feasible in the real world. We moved to a dual chain system with 90-degree idlers to better move the buckets around our system. Our original design was made of steel. However, due to budgeting concerns, we quickly had to pivot and go to wood. However, this change allowed us to create a more stable and robust outline for our frame. One of our major concerns was the power available from our motor, which is 1/8 horsepower. So we did a load analysis modeling the chains as ropes. Our calculations indicated that the motor did indeed have enough power to rotate our system. One of the most lengthy processes for this project was custom designing the sprockets we needed to go with our link chain. The main parameters that needed attention were the sprocket diameter as well as tooth length. If these parameters were not tuned properly, we found that the chain was not biting on the sprocket and would fall off.
One risk that was determined was the remote activation of the EDU. We needed to ensure the remote could transmit far enough while also not interfering with zoo communication, which operated within 450 MHz to 470 MHz. Here we have the 3 iterations that the remote and receiver have gone through. On the left is a 315 MHz basic receiver and transmitter which use lengths of transmitted signal to dignify zeros or ones. In example, 10 milliseconds is a 0 and 30 milliseconds is a 1 to transmit data. This was difficult to program and also only reached around 5 feet at max. Next was a LoRa transmitter operating at 915 megahertz. This was a more complex but easier to program device. It used serial peripheral interface to communicate between the Arduino and the transceiver. After testing with a monopole antenna, we achieved a consistent range of 10 feet while obtaining a maximum range of approximately 65 feet. The final iteration is a 433 megahertz HT Lynx transmitter and key fob. Upon testing, we obtained a range of 450 plus feet, and upon testing within the zoo, we achieved the requirement of activation from 75 plus feet, and with zoo communications occurring in tandem. There is minimal setup as the kit comes pre-built, and signals already output a voltage that can be sent to the Arduino.
We began our work on the project out of one of our team members' garage. Once most of the frame was together, however, we quickly realized that the frame was far too heavy to lift on our own. Because of this, arrangements were quickly made to transport our machine to the machine shop on campus. By the time we transported our system to the shop, we were already running behind schedule, as many of our tasks were taking a lot more work than what was expected. We had to work quickly to reassemble our system and get it upright at the shop. Once the system was upright, we worked on getting our chain system working. Once we installed the link chain, we were able to install the motor chain and rotate the system successfully with placeholders for our buckets. Once we were successfully rotating the chain around the sprockets, it was time to add the buckets to our system. Issues were arising with axle alignment. Steps were taken to realign the axles and make sure everything was in its place. Unfortunately, we were still struggling with the bucket rotating through the lower 90-degree pivot point. We were able to load a volleyball into the bucket and rotate it up and over to simulate dropping an item into the habitat. However, since we were not able to get the bucket to complete its full rotation, this is not entirely a verification of the full implementation of the EDU. However, it is a reasonable proof of concept.
At the time this video is being recorded, there are a few outstanding steps that need to be taken to completely deliver the device at Reed Park Zoo. They are outlined here, and the only major changes that need to be made to the actual design are the implementation of an anti-sagging system for the buckets. Outside of that, the remaining items on this list involve the delivery and final installation inside the habitat at Reed Park Zoo. These final steps will be conducted after design day, and they have been agreed upon with the sponsor, Reed Park Zoo. Through the process of designing, building, and testing the EDU, our team had many takeaways from this project. First is that it's extremely important to conduct thorough research on current technologies on the market prior to making major design decisions. Second, we learned that it's extremely important to account for the fluctuation in price of goods when budgeting, especially in times such as post-COVID-19. We also learned how important it is to establish clear lines of communications to keep all project stakeholders informed throughout the project. The fourth lesson we learned was the importance of reaching out to industry professionals and experienced individuals in the fields we are working in. And our final takeaway from the project is the importance of early prototyping when possible. We would like to thank our mentors, Scott and Heather, along with Reed Park Zoo, our sponsor, and all the staff at the U of A machine shop who helped us along the way. Thank you for joining us for Design Day 2022.